The gross domestic product per capita, this is question 3. We've got all this stuff here. They've given us the standard 6 key bits of information. Calculate the equation of the regression line of y on x for these 6 countries. This should be a really super safe 4 marks, because the number of times you get given these 6 bits of information and have to find the regression line is many times. So, what do we do with that? To work out the regression line, we're going to work out B, which is sxy over sxx. It's the standard regression line, isn't it? It's the one that's in the formula booklet that we've been asked for. So we just read it straight out of the formula booklet. That's going to be, well, it's just a case of putting the numbers in the right places. So it was 509900. That was sigma xy. Sigma xy minus sigma x times sigma y. So 7,000 times 450 over n, which I think was 6, wasn't it? 7,000. Oh, it's 456. Sorry. Over 6, is that what I wrote? 4, 5, 6. Have I got away with that? All divided by sxx, which is sigma x squared, 8,700,000, minus 7, is it 7,000? 7,000 squared over 6. We are going to very, very carefully put that into the calculator, and it gives us, well, I'll put the middle stage actually, it gives us minus 22100 over 5333. How many 3's are there? I think it's that, 533,333 and a third. And if we work that out, it gives us minus 0.0414 to 3 significant figures. Remember, we need to give answers to 3 significant figures, although you can leave it as a fraction, cancel down if you want to. We then also, from the formula booklet, A is y bar minus b x bar. So we need to work out A. We're going to do y bar, which would be sigma y, which was 456 over 6, minus our value of b, minus 0.0414, times x bar, which is 7,000 over 6. Okay, that's right. And that gives us 124.34. It's just a case of putting the right numbers in the formula. The formula's in the formula sheet. It's the same calculation we've done many, many times. So it should have been some relatively safe marks. And there we go. That's giving our coefficients to 3 significant figures. We get that. Having got that, part 2 asks us to it says the GDP for another country, Tanzania, is $1,300. Use the regression line in the diagram to estimate the IMR of Tanzania. So we're going to take 1,300, that's there, and estimate what that value is there. Well, we're reading up, there we go, that's across at that point. This is a gap of 10, that looks about a tenth of the way up. I think 71 is going to be a safe figure to read off. So we're going to say 71. You could use your regression line to calculate it, but 71. Now remember, what does it say about what this number is? This is, the Y number, is the infant mortality rate per 1,000. There were quite a few people who turned that into 71,000. But it's not, is it? That's not what it means. This isn't thousands of things. This is the number per 1,000. So 71, or if you really want to do it, you could say that's 71 per 1,000. That is the answer to that part of the question. The next bit says The GDP for Nigeria is 2,400. Give 2 reasons why the regression line is unlikely to give a reliable estimate for the IMR for Nigeria. Okay? Well, the first reason is the one that lots of people got, because it's kind of obvious. 2,400. This only goes up to 1,600 there. The biggest known value is 1,600. So 2,400 is quite a long way outside that range. So the first thing that we're going to say is that it's outside the range. And if you want to, you could just write the word extrapolation. I think, as I was marking your attempts at this, there were a few people who couldn't quite remember the word extrapolation, and so went for some weird and wonderful variations on that word. Most of them had an E at the start of them, but that was about as close as it got. We need another reason, because there are 2 marks here. So that, and it is therefore looking for 2 reasons. 2 reasons. So what's our other reason going to be? Well, actually, looking at the values here, these aren't particularly close to this straight line, are they? We haven't had to work out the product moment correlation coefficient, but it's not going to be a particularly strong correlation. Our other reason is that it isn't a strong correlation. If we are extrapolating, then we can only extrapolate if we have a really, really strong correlation. And especially once we've got these 2 things together, then that would suggest that that value would be unreliable to work out. Now, part 4 asked you to do quite a lot of working out here. Part 4 said the actual value of the IMR for Tanzania is 96. The data for Tanzania, X is 1300, Y is 96, is now included with the original 6 countries. Calculate the value of the product moment correlation coefficient for all 7 countries. Just notice this, because a few people forgot that N has now gone up to 7. So we need our 6 key bits of information to be updated to include this new thing that we know about. So if we think about what effect that would have, our new N value is 7. We work through them in order. Our new sigma X value is the sigma X value that we started with, 7,000, plus the new value for X, 1,300, so that gives us 8,300. Our new sigma X squared is the old value plus the new one squared, because that's what it means. It means the sum of all the values once the thing's squared. So we square 1,300 and add it to the original value, and that gives us quite a big number. We're going to do the same thing for sigma y. We're adding on to the old sigma y, which is 456, was it? The new value, which was 96. The old value was 456. Add on the 96, and we get 552. Square 96, and add it onto sigma y squared, and that gives us 45478. And the last one, now remember the last one is sigma xy, and this is what you get when you multiply the x's and the y's together and then add them all up. So we need to multiply these new 2x and y values. That would be 96 times 1,300, and add that, whatever it gives us, onto the old value, which was 509,900. That gives us a new sigma xy of 634,700. All that's left now is to use those new calculations to work out the value of R. So it's just about being careful with your calculation now. Sxy over sigma, over square root of Sxx Syy. I actually did this all in one go with these. So I put in, this is 634,700 minus 8300 times 552 over 7 divided by the square root of Sxx, which is sigma x squared minus sigma x when you square it over 7, multiplied by sigma y squared minus sigma y when you square it over 7.
It's not working out.
Really careful with typing that all into the calculator, calculating it all, and getting minus 0.606 correct to 3 significant figures. We also ought to have some kind of feel for what that number is going to be like, so we know if it's wrong. For example, if that is outside the range -1 to +1, it's got to be wrong, because that's, r is between those two values. So that's the first thing to look for. If that comes out as a positive number, it's kind of got to be wrong as well, hasn't it? 1396, that's 1386, that's about there, isn't it? It's still going to be a negative correlation, isn't it? That's not changed things enough to change that. So we're kind of expecting a figure somewhere in the region, I don't know, maybe -0.4 to -0.7. We're thinking that's that kind of area. It's not a particularly strong negative correlation, we're not close to a straight line, but it's definitely a negative correlation. And so we ought to have some understanding that the value we get makes sense. Part 5. The IMR is now redefined as the infant mortality rate per 100 instead of per 1,000, and the value of R is recalculated for all 7 countries. Without calculation, state what effect, if any, this would have on the value of R found in Part 4. We made a really big deal about this when we first started doing the correlation coefficient. All that stuff about how we do such a complicated calculation to make sure that it's independent of the units of measurement. If you change from meters to centimeters, if it's height that's in there, it doesn't make any difference. It doesn't matter what the units of measurement are. And that's all that we've changed here. We've changed the units of measurement. So the correlation, the relationship between the two things hasn't changed at all. All we need to say is no effect or no change. And that's it. Let's get our plan and mark for that. And that's